Good morning, everybody. I hope you guys are doing alright. I just wanted to take a second and go through the conceptual questions that I asked you guys to do today. I hope you guys are doing well. Hope you guys are getting to relax a little bit, not going too crazy from having to spend all this time by yourself at home, quarantine. But yeah, I just wanted to take a second to go over all this. I'm hanging out, getting a little tired of being home, miss work. I was hanging out with the dogs all day. What's going on, man? He's about to fall asleep because he's doing physics problems. He hates it. Huh? What's the other one? I don't know what the other one is. The other one doesn't love me. Paul, come here. Come on. All the way. There he is. What's up, bud? Yeah. So, we're hanging out. But I thought I'd go through some of these with you guys. Make sure we're all on the same page. Yeah, you understand a little bit about static electricity. So, at the end of the PowerPoint today, there are 8 questions I want you guys to try out. They're all concept questions, so there's nothing crazy going on. But let's do it. First question, if an object is electrically neutral, what can you say about the amounts of positive and negative charge it contains? So, if something is neutral, right, what can we say about the positive and the negative charge? And hopefully it's pretty straightforward, right? This one's pretty easy. If it's neutral, that means it's got a net charge of 0, which means there has to be the same amount of positive and negative charge. Right? And if there's the same amount, then those charges will cancel out and give us 0. Cancel out and give 0. Hey, keep it down. I'm trying to make a video here. Pause. Alright, so that's what we got for the first one, right? It has to be the same amount of positive and negative charge. The charges cancel out and they give 0. Shadow. Second problem. What does charge quantization tell us about the amount of charge an object can have? So, the key to this one is this word quantization, right? What does that mean? Quantization means that things come in like specific amounts. So, if we talk about electricity, right, and charge, charge comes in specific amounts. It only comes in increments of 1.6 times 10 to the negative 19. Right? Those are the only option, right? That's the only option we have as far as how charges can come. So, if something's going to have a charge, it has to come in an amount that's a multiple of this number, right? So, what are the options for charge? If we start to list them out, what's the next one that we could have is 3.2 times 10 to the negative 19, right? Because that's 2 times this. The next one we could have would be 4.8 times 10 to the negative 19. Then we could have 5.6, 6.4 times 10 to the negative 19. Right? Those are all possibilities, but you notice it's all in increments of this 1.6, right? 1.6 times 2 is 3.2. 1.6 times 3 is 4.8. 1.6 times 4 is 6.4. right? So they always come in that specific increment. That's what quantization tells us. Is the total amount of charge in the universe changed when we charge an object? The answer is no, right? Just like energy and momentum, charge is conserved, right? It's got a conservation law, which means the total amount of charge can't change. It just gets moved from one place to the other. So no, the total charge doesn't change. It just moves from one place to another. Total charge doesn't change. It just moves from one place to another. Alright, what we got next? Number 4. I didn't write out this whole problem because it was a long one, but electrically neutral object is given a positive charge. Does the object's mass increase, decrease, or stay the same? And then it gives us 3 explanations as to which one is correct. So, when we charge an object, right? Charging objects happens because we move electrons, right? Charging objects means moving electrons. Oh, shush. What are you doing? Go lay down. You're bothering me. Go away. Go lay down. You too much. Ignore me all day, and then as soon as I try and do something, he's all up in my grill. Oh, yes, I see. So, it means we're moving electrons. So if we want something to be positively charged, right, that means we have to take electrons away, right? Making something positive means we have to take electrons away. Because electrons are negative, so if we take away negatives, things become positive. Take away electrons. So making something positive means we're taking away electrons. And if we're taking something away, right, we're taking away electrons, what happens to the mass? The mass has to decrease. Right? If we take away electrons, mass has to decrease. So if you're looking at those options, right, option A, to give the object a positive charge means removing some of its electrons. This will reduce its mass, right? Take away electrons means mass has to decrease, right? And that's how we make something positive. Number 5, if rabbit fur is rubbed against glass, what will the sign of the charge each object acquires? Or what is the sign that each object acquires? So to do this, we got to look at a table from earlier in the chapter. It's actually, I think I had on there this slide number 13. I think it's actually slide number 12. But if we check this out, right? Here's our table. We've got rabbit fur, glass, human hair, nylon, silk, paper, cotton, right? The higher up on the table, the more positive something wants to be, right? So if we take something and we rub it something higher on the table with something that's lower on the table, the higher thing on the table will become positive and the lower thing on the table will become negative. So for example, right, our question here says rabbit fur and glass. So if we rub rabbit fur with glass, because rabbit fur is higher on the table, it will become positive and the glass will become negative, right? If we take like rabbit fur and paper, right? Rabbit fur is higher on the higher on the table than paper is, so rabbit fur becomes positive, paper becomes negative. we could even go down to the bottom, right? Let's, for example, something like PVC and Teflon. If we rub PVC and Teflon together, PVC is higher on the table, so it becomes positive. Teflon becomes negative. So the easy or the quick answer to this question, right? If rabbit fur, rubbed against, what's this, rubber? Rubbed against glass, what is the sign of the charge each object equals? Well, because rabbit fur is higher on the table, rabbit fur will become positive. And the glass will become negative. Right, the rabbit fur will become positive because it's higher on the table. Glass will become negative because it's lower on the table. 6 and 7. So, number 6. The system consists of 55 electrons and 43 protons. Is the total charge of the system positive or negative? That, I hope, is pretty easy. Electrons are negative. Protons are positive. We have 55 electrons, 43 protons. Means we have way more electrons than we have protons, which means the total charge is negative. Right? Because we have more electrons. What is the total charge? So this one is actually, I think, can seem complicated, but it's really not that bad. What's the total charge? So what we want to do is take the electrons and protons and subtract them from each other, right? See how many extra electrons we have. So if we take 55 minus 43, that'll give us 12. So the total charge we can write as negative 12 E, right? This means we have negative 12 extra electrons, or we have 12 extra particles, and the negative means they're electrons, right? So this right here is how we're going to write the total charge of the system, negative 12 E. We throw that E on there to let us know that we're talking about electrons or protons, right? If it's negative, we're talking about electrons. If it's positive, we're talking about protons. The E just represents the charge, right? Charge on electron is negative E, which is negative 1.6 times 10 to the negative 19th coulombs. The charge on a proton is positive E, which is positive 1.6 times 10 to the negative 19th coulomb. So if we have negative 12 E, that means we have 12 extra electrons. If we had, say, like positive 12 E, that would mean we have 12 extra protons. So total charge, we just subtract them, and positive or negative for whichever one's higher. In this case, it was electrons, so we put a minus, a negative, and then tack the E on at the end. Will let us know that that's the charge. 7, system consists, I messed up, I started writing the wrong thing, of electrons and protons only. It contains 150 electrons, and it has a total charge of positive 22E. So positive 22E, right, that should tell me there are 22 extra protons, right? Because it's positive, I know this is protons, so the total charge tells me that there's 22 extra protons. So if we have 150 electrons and there's 22 extra protons, that means we have 150 plus 22 gives me 172 protons. We get 172 protons. Easy peasy. Last but not least, right, number 8, very similar to number 7. We have a system, again, just electrons and protons. It has 320 protons and a total charge of negative 51E. That negative 51E tells me I have 51 extra electrons. And if I have 51 extra electrons, we take the 320 plus 51 gives us 371 electrons. All right. I think that is it for today. Just submit that for me, right? Whether you wait till after the video, you watch the video, or you do it before the video, whatever. But this is there, hopefully, just as a guide for you guys to help you out answering some of these questions. All right.